Alright, let's do this. Alright, 1 November the 24th. Alright, let's get to it. So today's goal is to redo this one. It will be like the third time we do this. I don't remember how I solved it. But I know it's DP, so it's a 3-level DP. Nah, I'm just gonna Python this, so don't have to think about. I know the solution is very simple if I can figure out the DP part. Alright, let's try this one first. Sum of absolute difference in a sorted array. You're given an integer array num sorted in non-decreasing, so it's increasing, or it's the same. Build and return an integer array result with the same length as nums, such that result I is equal to the summation of absolute difference between nums I and all the other elements in the array. In other words, results I is equal to sum nums I minus j for every single j. I mean, it doesn't matter because like j not equal to I, it doesn't matter because if it's equal, it's just going to be 0, so it won't affect. Alrighty, we have 2, 3, 5. Okay, so what we have is 2 minus 2 plus 2 minus 3 plus 2 minus 5, right? And then 2 minus 3, 3 minus 3, 3 minus 5, and 2 minus 5, 3 minus 5, 5 minus 5. So this gives you 4. This gives you 3. This gives you 5. Okay. Let's think. How can we make it? For one thing, things just repeat themselves, right? Because there are only so many pairs. Oh, there's actually a lot of pairs. No. Unique pairs. Yeah, there are a lot of unique pairs. All right. There are a lot of unique pairs. So for the first one, I get this, right? Basically, it's just so it's some sort of prefix sum, right? Because if you think about it, it's sorted already. For this, this minus this minus this is equal to 2 times, right? It's equal to 2 times, let's say, 2, right? 2 times 2, and then will be the sum of this. Yeah, so we're just gonna get a prefix sum. Do we need a 0? Do we need a leading 0 though? Let's try without a leading 0. So we have this, right? And then, okay, for this position, what we're gonna do is anything on the left-hand side. Maybe we need a 0. Maybe. Yeah, let's put a 0 there. Okay. So right here, so it's gonna be, we consider right and left. So consider left is gonna be 2 times however much is on the left, how many, right? So in this case, on the left, because this is 0, so times 0 minus this plus however on the right hand side, right? So it's gonna be to the end, so will be the pre-sum minus 1 minus this pre-sum I minus 2 times however many remaining, right? So in this case, it's going to be 10. 10 minus, it's not 10 minus this, 8. 8 minus 4 equal to 4, right? So in this case, left, so we have 3 minus 2 plus right is going to be 5 minus 3, right? That's 3. For 5, on the right hand side, ooh, right hand side, maybe we just don't consider, oh, on the right hand side, we have left hand side, so it's be 5 times 2 minus 5, right? So 5. Right hand side, if you want to do it, it's how many on the right? It's actually 0, so 5 times 0 minus, we don't have anything on the right hand side, therefore if, you know, we just, the first one we consider separately, last one consider separately, and then we do everybody in the middle. But I kind of, you know, want to do the last one also. But the last one on the right hand side is a little bit troublesome. We know it's 5 times 0, but minus what? I don't have anything else to minus. Oh, it's actually, we do. It's just minus 0. Yeah, we do. Because we do is minus 1 minus its index. So it's going to be 0. Okay. So it's not very difficult. Oh, I think I need to exit it and reopen it because I just changed the Vim binding. Okay. So J's go down, K go up. J go down, K go up. J go down, K go up. All right, K go up, and we're gonna go to the, oh, no, that's not right. I'm gonna go here. So what's the first thing? First thing is to create a prefix sum, okay? So what we're gonna do is int pre-sum goes to new int nums.length plus 1. Okay. Next, what we're gonna do is for right int I go to 0, I smaller than nums.length I plus plus. Come on. Okay. And we say pre-sum I plus 1 equal to pre-sum I plus nums I. Right? Pre-sum I plus 1. Yeah, but pre-sum 0 is 0. Okay, so that's the prefix sum. Okay, now what we're gonna do is int res equal to new int nums.length. Okay, and that's not right. Therefore, we're gonna, hold on, find JK. Yeah, JJ. Go down. Now we're gonna say for int I equal to 0, I smaller than nums dot length. Actually, that's not. Okay, it's fine. Okay. All right. So for each one, what we're gonna do is so nums I, right, times I is the number on the left hand side minus pre-sum well, it should be to the left, so it should be I minus 1, but I minus 1 also had the plus 1, so it's pre-sum I, right? So plus nums, no, plus pre-sum pre-sum dot length minus 1. Right, is the last one minus pre-sum. Now it should minus I, right? But it's a representation of I in the pre-sum, so it should be I plus 1. Because if it's 0, we should minus this. Okay, so we minus that. That's the right hand side, and minus nums I. Okay, times how many is left? How many on the right hand side do we have? All right, in this case, I think we did a lot of. So what we're gonna do is do a n equal to nums dot length. Okay, so with that, every single nums dot length can be replaced. So we're gonna use %s nums dot length. We're gonna replace with n. This one is no. This one is a yes. Yes, yes, yes. Okay. Then what we're gonna do is we're gonna go for pre-sum. Next. This is gonna be n. Yep. So what we're gonna do is ci this. We do n. And then pre-sum and then times. So we're gonna go to this. N is the total length minus I minus 1. Minus I plus 1 is how many up to me. Yeah, so this is okay. So that's that. This is going to be, so we're gonna go to the front of this. Then this we're gonna say res I shall equal to this. Okay, and if res I is equal to this, we might as well also delete. So we can delete this, go down, delete this, and then return res. Okay, so we go up, go to the front, copy this, and give it a run. It's good. Yeah, I think we can go. I think I can even write. Okay, code this. Use prefix sum. That's on. There's no sorting on anything. All right, let's check the solution. Prefix sum. Check. Yep. Calculate prefix sum on the fly. How do you calculate on the fly? Oh, yeah, I just need a total sum, right? Huh. Good point. Let's go back to here. V, and we're gonna go up. Update from the official solution. We learned that there is no need to create a prefix sum array because all we need is the prefix sum up to the current value and a total sum. That is correct. Which means we do this, we don't do this, we do So we delete this, and then we say int pre-sum, that's still gonna be 0, and int total equal to 0. Okay, and then we can just so we define this total plus equal to numSi. And this one can be simplified. I'm pretty sure it's going to tell me this one can be simplified. And I will oblige. Yeah. Okay, so we have the total. We have the prefix sum. And this is necessary. So we go through this. We need this. That's okay. We put this in. Go up here, and we're gonna. Oh, that's not what we want. So pre-sum plus equal to numSi. Okay, we get the pre-sum. Then what? Then we say this will be this. Pre-sum, which is the pre-sum excluding myself. Right, so I shall say minus pre-sum minus numSi, because I have to exclude myself, because the pre-sum includes myself. Then why don't you do the pre-sum afterwards? I guess it's fine. We just do that, and this is just going to be go to the next one. It's total, right? Minus pre-sum. That's important. Total minus pre-sum. And then minus the rest. Okay. Let's take a look. Is this correct? Is not correct. Okay, something's not right. Okay, we get the pre-sum, right? Minus pre-sum, and this should be plus. Or we can, we can do minus, but it has to be like that. There we go. That is the stuff. Okay, so this is done. Good. Don't need you. Don't need you. Don't need you. All right. Oh, I don't want to sail. Okay. All right, let's take a look. You're given 3 integers, n and k. Consider the following algorithm. All right, so this is from left to right, max value. Every time the current value is bigger than the max value, the cost increment, right? Should build the array, we'll build an array which has the following property. Array has exactly n integers, okay? N integers. In the range 1 to m. After applying, the cost is k. So basically we say there are k like new max values, number of ways to build the array. Ugh. Okay, what do you remember? So every time a big value pop up, so we have something something boom pop up, something 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 boom pop up, right? So every time we have something pop up, we'll record. And I think the DP's condition is What's the DP condition? The maximum encountered so far. The maximum encountered so far. Okay. So we're at, so it's going to be, we're at position I. The maximum encountered so far is P. Okay, that's the maximum encountered so far. Right, the maximum encountered so far is P. And we have so in total we need to have K maximum encounter, right? K maximum encounter. So isn't that just the R, which is the remaining max encounter allowed? Does that work? So the answer will be starting from 0 with the max encountered is 0. And then we have K allowed. So that is the answer. Okay. So for dpibr, right, we are at a position. Okay, we are at a position I. We say the max encountered is P. So this is previous to max, right? And now we have R remaining. So at this I position, right, this I position, if I get a value smaller or equal to P, right? If my I position is smaller or equal to P, I have if I'm smaller or equal to P, which will give me P different ways. But actually, this is, we shouldn't start with 0. We should start with 1. Previous max, it should be 1, because the smallest is 1. So if array I is smaller or equal to P, then we have P ways, right? So 1, 2, 3, all the way to P ways for this. And then we can do next. So it'll be P times dp. We basically go to I plus 1, saying the previous P, and we still have R left. And if array I larger than P, then we have, M minus P ways, right? Basically P plus 1, P plus 2, all the way to M. So we do M minus P times dp I plus 1. Oh, what are we going to do here? What the previous max, depending on what the new thing you give. And this will be R minus 1. What is this one? There's trouble. Trouble. Nope. So instead of doing this, I believe we shall do another way. Because we have to go through every single one, right? So I think it should be for, next P, NP, right? For NP in P plus 1 to M, because we can go M. We do DP I plus 1 NP R minus 1. Right, and then we just plus equal to this thing. Okay, let's give this a shot. What is this problem? 1420. Okay, let's do this. Okay, we will do def dp I p r. Oh no. Oh, maybe I have to, hold on. I have to turn this off and turn it back on. Nope. Shoot. Sublime text vim vimrc vintage mode. Under the hood. No, it didn't go to. Oh, this is. I don't think it does vimrc, right? You know what? You know what? You know what? Why we do this? Why we do this? Huh? Why we do this, man? Why we do this? Come on. You want all the Vim stuff. Here is all the Vim stuff. What's the difference between this and Sublime Text? There's no difference. Right? You can do whatever you want. That's exactly what you want, right? Yeah, it is exactly what I want. What it doesn't, oh my goodness. I have to, okay, I don't like that. Indent. Vim, oh shoot, Vim auto indent. I did. I have shift with 4. Oh, that was for auto indent. Hold a second. Let me Vimasi. Okay, so we're gonna say Vimasi. So this is auto indent. Set tab stop. Hold on. Set auto indent. How many spaces? I think it's just set auto indent. So we can say this is auto indent. I don't know about this, so we can just say set auto indent. Set tab width. Expand tab. You know what? I have no idea what these things do. Hold on. Let me undo this thing. So we'll do a new one. Set auto indent. Okay. So we'll say set auto indent. Set tab width equal to 4. Tab width. Tab. Right? Tab. Set tab width equal to 4. Set tab width. Set auto indent. Actually, it depends, right? It could be 4. It could be 2. You know what? I shouldn't do this line. I should just, we'll go vim. Right, and then we'll just set tab width equal to 4. Unknown option, tab width equal to 4. Holy crap. Set tab width equal to 4. Ah, this one works. Alright. So let's say we go here, we go indent. Ah, okay. It works. Go here, okay. So, what we need to do, I want to say, I is, oh shoot, what do we do? Go up, it, what? What did I do? This is broken, man. Wait, this is. Which one? Which one does this? Okay. Hold on, let me try it again. I think it's TW. Which means maybe those other things are. Then what if I want to tab? Hold on. I think the tab stop for might have something to do with it. Tab stop equal to 4. All right, what if I, let me see if we can comment out this. So we do that. Let's try. That's 8. We jump 8. So tab stop. Okay, tab stop. That's what I need. That's what I need. Tab stop. Okay, yep. We're gonna quit again. And then we go to here, tab stop. Okay, so we will do here, we're gonna delete this line, go down this line, and we paste this, delete this. Add command, add command this when you want to have tab equal to 4 spaces. Okay, I think this should be fine. Okay, so we go back to here. We can say set tab stop equal to 4. Okay. Then when I go down, yeah, that's good. So I go up. Ugh. It doesn't. That's fine. All right. So we say I is the index on the created array. P is the previous max value encountered in array. Encounter. I didn't spell right. In array. R is the remaining new max value allowed. And this is related to K. Okay. So what we're gonna do is, of course, if. So what's the edge case? Well, edge case is if R is equal to 0, right? We have no more K left. And we have I is equal to, yeah, if I is equal to n, so we walk all the way to the end, right? We say if I is equal to n, if I is equal to n, then we need to check on R. If R is equal to 0, so walk to the end, and then this is will return 1. Otherwise, we'll return 0. Right? If I is equal to n, yeah, this we still need more customization for this, because the return I want to go tab as well. Delete I want to go tab as well. maybe I have, you know, yeah, I have this. Yeah, this is okay. And if I is not equal to n and r is equal to 0, right? So if r is equal to 0 but I is not equal to n, so we haven't walked to the end, but we have exhausted everything, and this is gonna be I have no idea. So this is gonna return 0. Right? Okay. And then what? And then we're gonna say let current value be not larger than p. Okay. And we also do need a result, right? Here's a 0. We also need, let's go up. Mod is gonna be 10, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we go down. Right, so let value be not larger than p. Then we have, I don't know how you do this. We can rest shall equal to p different ways times dp I plus 1 pr, right? And we'll mod, that's fine. Okay, let current value be larger than p. Then for next p in range p plus 1 all the way to m, rest equal to rest plus dp I plus 1 next p r minus 1 mod, and then we'll return rest at the end. Okay, then we will return dp. We start with 0, previous max is 1, and r is k. Okay, so we also need to do from functools import value cache, and let's go down at value cache size equals none. Okay, we cannot run it directly here. No, we cannot. So what we're gonna do is we have to save this. You have to go this one still. Yeah, but I have to say, like, you see this? This is really nice. But it's still, I think the only thing that's not nice is I cannot map JJ. Oh, maybe I can. Maybe I can. Why do you highlight this? Can I map? Sublime text. Map JJ to ESC. Ooh. Keys, command, exit, insert mode, context. Okay, so go here, preference, key bindings, right? Oh Lord. Oh, I already have it. Oh my God, can you format this? It is ugly as hell, man. JSON format. Okay, I think. Yes. Okay. Alrighty. Let's check. It works. Oh yeah, it works. Oh, nice. Upvote. I mean, this is actually the same as this one. Exit in symbol, yeah. Okay, so we got that. Now we don't have to go to Vim. You want to test it? Yes, let's test this. So we're gonna go to here. So 2, 3, 1, 6. All right. Next one 5, 2, 3, 0. 9, 1, 1, 1. Then here B B B N M K. Go down. This is num of arrays. N M K. Run it. We have an issue. Of course, I go 9 up. Find this. Go back. Do this. That's why I have it underlined. Of course, this is not solution 2. So we go down, find 2, delete it, and run it. Ugh. That's not right. Okay, something is not right. It's okay. Oh, that's not right. Yeah. Because I don't have to go all the way to the end. At any time that r equals to 0, I shall be fine. Because the remaining value can just be small, right? It just can be small value. It doesn't really matter. So it's if I is n and r is not 0, that is a concern, right? I go to end, but r is not 0. That shall return 0. And if r is 0, that shall return, yeah. So we're gonna change line 17. Actually, we're gonna delete this, to delete the next 2 lines. Now, I'd like to say delete up to here, right? And we're gonna go to here. If this and r is larger than 0, return 0. If this, return 1. Ugh. Okay, that's still not right. Huh. I am thinking. I is n. N integer, so you go all the way down as the last one, and still odd logins. So in this case, there's no number of ways, right? We're trying to find the number of ways, and if odd is equal to 0 at any point of time, odd is 0, so I don't have any remain. Oh, that's now 1, right? That's now 1. Huh. That's now 1. No. There's some combination happening, so, but we don't want to do the combination here. So let's say 2dd, right? And let's also delete up into this. Should turn 0 if odd is larger than 0, else 1. Ugh, it's still not right. Or r might be smaller than 0. Okay, so I think I need to handle this r smaller if r is smaller than 0. If r is smaller than 0, this will return 0 for sure, right? If I is, then we say no, still not right. Come on. Come on. What did I get wrong? Did I do a top down? Jeez, man. Oh, I think the only difference is a DP start. Should be 0. Really? It should be 0 to start. DP 0, 0, okay. Really? That makes a difference. Huh? How do you know? It is 0. previous max. Previous max has to be 0. Why 1 is not right? Because we're trying to each value previous max value. If I go 1, previous is 1. Okay. The m is 1. If previous 1, m is 1. Oh. Previous is 1. But then this shall work, right? It's still 1. I don't understand. Why the previous, why we need to start with 0? Result is 0. So we start with 1. M is 1, K is 1. So come in 1 1. And then this one doesn't go, right? Because this is just go all the way down. So we take 2. And we cannot take 2. So this one don't go. So return is 0. Interesting. It had to start at 0. What do you think? Well, I think we need to do one more time. Just save this and we hit it one more time. I don't think it's enough. Oh, there's new things. Oh, no, it's all right. Yeah, I'm not trying those. All right, that'll be it for today. Yeah, I'm gonna do this one more time.